Okay? You probably have heard this phrase over and over for your entire life. But why is it the most important meal? And what happens if we just, skip it? Well, breakfast is an extremely important meal because it gives you the energy you need to start the day. You literally are breaking the overnight fast. And eating breakfast has also shown to contribute many health benefits, such as weight control, improved physical and cognitive performance, and improved metabolic biomarkers. But is breakfast really the most important meal of the day? Let's face it, chances are that you know someone who seems to be very healthy, but doesn't really take the time to eat breakfast. Well, it turns out that researchers can't agree either. And several observational studies have reported that people who skip breakfast tend to weigh more overall. And this observation may go against the common thought. For example, if you want to lose weight, eating 2 meals instead of eating 3 meals means you're eating fewer calories, doesn't it? Well, not necessarily. One theory is that breakfast skippers tend to get hungrier faster and therefore eat more calories later on throughout the day than regular breakfast eaters. The theory goes like this. Skipping breakfast results in spending the rest of your day making up those missed calories at the end, resulting in overcompensating and eventually leading to excess unwanted weight gain. However, most of these reports have come strictly from observational studies with little data from an experimental cause and effect setting. This means that many other factors could contribute to the weight gain aside from just not eating breakfast. So, in contrast to the common belief that skipping breakfast always leads to weight gain, randomized controlled research trials have actually shown that these common theories and myths about breakfast are hard to confirm. For example, when 2 groups of overweight and obese individuals were randomly assigned to either breakfast or to refrain from breakfast, there was no effect on the amount of weight lost in each of the groups. Another randomly controlled trial with lean individuals showed that skipping breakfast did not cause weight gain, nor did it lead to changes in resting metabolic rate or the number of calories that subject burned at rest that are required to sustain your basic physiological functions. Also, the overall daily caloric intake was the same whether the lean subjects ate breakfast or not. And this means that in this study, skipping breakfast did not lead to eating more over the next few meals. Now, one interesting difference, though, was that both afternoon and evening blood glucose levels were more stable in the group who ate breakfast as compared to those who fasted until noon. And stable blood glucose is usually a great sign for good metabolic functioning. In fact, if blood sugar is consistently high, this can lead to a host of other issues, including insulin resistance and even diabetes. Long story short is that there is no clear-cut answer in the research saying that breakfast is the key to gaining or losing weight or improving body composition. And oftentimes I'm asked, should I eat breakfast? And my answer is, well, do you like breakfast? I do this because what I've seen is that the key to making lasting improvements in body composition comes from working small exercise and nutrition habits into someone's lifestyle, rather than flipping their lives upside down from the start. And one main point to consider is that on the outside, if you eat breakfast or skip it, or you eat often or just once a day, every bit of food you eat has a dramatic impact on your body composition and your health and how you feel. So let's talk about what exactly happens to the food that you eat. How does it enter your body for storage as glycogen or stored carbohydrate, as fat or as protein? Well, many processes must happen inside your body to prepare the food you use for storage or to be burned as energy. Now, before the food you eat can be used as energy, it needs to be broken down further inside the body into the individual nutrients. And this process is called digestion. And then following digestion, the body must take up or absorb the individual nutrients to create either use them or store them for later. This is called absorption. The bulk of this lecture will focus on the details of digestion and absorption, and we'll touch on how the aging process can interfere with normal digestion and absorption, and how that can affect body composition overall. We'll also talk about nutrient partitioning, which is how we use foods and how we can partition them into storage as fat or into storage as muscle based on our physical condition. Now, foods and beverages provide your body with nutrients that it needs to sustain itself. Now, that's pretty common. Now, the nutrients from our body, though, are split into two main categories. We have macronutrients and we have micronutrients. The macronutrients consist of carbohydrates, fats, and proteins. And these are used by your body cells to create energy. But the micronutrients, including vitamins, minerals, and water, do not provide calories or energy. But they are required for many physiological processes in the body, including digestion and absorption. You'll hear much more about the macronutrients and the micronutrients later in this course. But for now, to fully understand the digestion and absorption process, we will start with a brief overview to trace the food from the time it enters your mouth all the way through when it exits as waste. Once you take a bite of food, the first section of the gastrointestinal tract, or the GI tract, that it hits is the mouth. And obviously, the food then travels down the esophagus and enters into the stomach to be chemically and mechanically broken down into smaller fragments. And then after the stomach, these food fragments enter the small intestine, followed by the large intestine. And then whatever nutrients and materials the body does not use up along that process, they are excreted through the rectum and the anal canal. Now, along the route, your pancreas, gallbladder, and liver all help to digest and absorb the food by producing various enzymes. And these are specialty proteins that help reactions occur in your body. And the enzyme solutions they make also help with the breakdown and transport of foods. So, that's the brief overview. Keep these major organs in mind as we dive now into some more detail. Almost all nutrients within the food you eat must be digested before they are absorbed. And various physical and chemical activities from the mouth, the stomach, the pancreas, and the small intestine are responsible for digestion. And once you take a bite of your food, your teeth and your jaw muscles take care of the chewing of the food and mixing it with saliva to make the food easier to swallow. The water in your saliva, along with two major digestive enzymes called alpha amylase and lingual lipase, begin to dissolve and chemically digest your food. Yes, technically, digestion begins in your mouth. And once the food is mixed with saliva, we now refer to it as a bolus. The bolus leaves your mouth and travels through the pharynx and into your esophagus. The esophagus has a sphincter at the top called the esophageal sphincter. And this separates the oral cavity from your pharynx. Then, a wave-like neuromuscular movement known as peristalsis occurs progressively to move the bolus of food down your esophagus. And then another sphincter, called the gastroesophageal sphincter, separates the esophagus from the stomach. And this is where your food is headed next. So this entire esophageal process usually takes about 10 seconds until the bolus of food has moved from the top to the bottom of your esophagus and then enters into your stomach. The stomach is the major site of chemical digestion, where any larger food items are broken down into individual nutrients. For example, large carbohydrates are broken into individual sugars, and large proteins are broken down into individual amino acids. This has to occur because whole carbohydrates, fats, and whole proteins are just too big to enter your body from your GI tract. So it is the smaller building blocks of the larger macronutrients that are needed to actually enter your body from the GI tract. So while the mouth and the stomach are referred to as digestive organs, they do things a bit differently. The mouth mainly takes care of the physical breakdown of food through chewing, and the stomach takes care of the chemical breakdown of food using very specific enzymes. The first enzyme is called pepsin, and pepsin breaks down large proteins into smaller amino acids. The second enzyme is called alpha amylase, and this enzyme may sound familiar to you as it already came into play when our food was still in our mouth. Alpha amylase breaks starches into simple carbohydrates. But not for long, because the acidic environment of our stomach actually stops the majority of the alpha amylase activity. Now, the third enzyme to take note of in the stomach is called gastric lipase. This enzyme breaks down some fats into smaller components that are easy to absorb. Along with these three main enzymes, several other hormones and secretions play a role in the chemical digestion activities of the stomach. So the stomach is where partially digested food is mixed with stomach juices and enzymes to create a substance called chyme. And once food is fully mixed and the chyme is ready to be emptied out of the stomach, it moves through yet another sphincter called the pyloric sphincter and enters into your small intestine. Now, the small intestine is your main site for finishing up the digestion process. It is also the main site that absorbs all of the nutrients that you've just broken down. And although its name says small intestine, this organ is far from small in both length and in importance. For example, if you were to unravel the small intestine into a straight line, it would stretch out to be about 20 feet long. Also, the surface area spreads out to be about 300 meters squared. So picture a 3-foot wide walkway that is more than 3 football fields in length. This is the amount of space that your small intestines would take up. Now, this is a huge surface area, and it's a unique aspect of the small intestine as it allows us to maximize digestion and absorption. The reason the small intestine has such a large surface area is due to circular folds known as the folds of Kerckring. Now, these folds have many finger-like projections called villi that project off of these folds and into the lumen, or the inner side of the small intestine. And hundreds of these intestinal cells line the villi in order to absorb and transport the nutrients. These cells are called enterocytes. And these microscopic structures, called microvilli, are tiny, hair-like projections that make up the villi themselves. Now, these small microvilli make up an important section of the small intestine, known as the brush border. It is within the brush border where all of the intestinal digestive enzymes are produced and stored. Almost all of the digestive activity in the small intestine occurs in the brush border. Now, once all the nutrients are broken down into their simplest forms, they are then taken up into the cells of the GI tract to be transported throughout the entire body. This process is known as absorption. Most of the carbohydrates, fats, and proteins that you consume are generally absorbed within about 30 minutes.